Okay, so we're going to be looking at first. We're going to review procedural programming, or what's more correctly called structural programming, is what we've learned up till now. And I like to refer to procedural programming because it kind of it's easier to understand maybe if you haven't heard these terms before. But basically, the idea is, we've been creating memory locations that we call variables. And then we've been writing a series of steps or operations to manipulate those variables. And it's kind of like a checklist that we're giving the computer, and it does one thing after the other and displays results. Some of the terms we've used are identifier. Basically is a one-word name to use to reference a variable. And really, the identifier is the name of the variable itself. The variable consists of an identifier and then underlying data that's stored in memory. And then we have procedures or methods, or we started by calling them functions, but when we get into classes, we're going to see that we call these things methods. And what the functions basically do is they're just a logical unit of, a small unit of steps that we're doing. So really, we can think of a function as a collection of statements that does something, and a program is maybe a collection of functions and statements that does something. And we say that we call or invoke a function. So just a review of some language. Does all that seem is that all that makes sense? So when we talk about object-oriented programming, we're talking about really another level of organization above functions. So it's not that you do object-oriented programming instead of functions or structural programming. This is just another layer of organization above that. And so it's an extension of the structural programming or procedural programming. And originally when object-oriented programming was created with C++, a gentleman by the name of Bjarne Stroustrup took a language called C, and then took another language called Simula and put them together. And what Simula was a simulation language, and it was used to represent objects in real space. So object-oriented programming really is kind of the art of breaking up your code to kind of represent the things that you're representing in the real world, and then making a model for those called a class that you can then create multiple objects from. So objects are similar to real-world objects, and we represent them with variables and functions, and a function which is associated with a class in object-oriented programming is called a method. So, and we also often call the variables themselves attributes. So the attributes of an object, which are variables, basically maintain the state of a particular object. And the behaviors of an object are defined using functions or methods. And we take these functions and these variables and we define something called a class. And once we have defined this class, which says that, for example, every car should have a number of wheels, should have a fuel capacity, should have an owner, should have a color, should have a make, should have a model, we could use those kinds of things to define a class. And then from that, we could use those variables or attributes to define Joe's car or Susan's car or Fred's car. So from one class, once we define it, we can reuse it to define multiple objects from that one class. Does that concept kind of make sense? So the classes allow us to implement something called the dry concept. Dry in programming means don't repeat yourself. And it's one of the central things about being a programmer. If you find yourself copying and pasting or writing the same code over and over again, most likely that probably should be a function or maybe even a class. We're not going to talk too much about encapsulation with in the context of Python. It doesn't use a lot of private and public encapsulation, but one things we can do with classes is also hide things inside the class to keep them from being accessed, so that we can make a class that kind of protects itself from misconfiguration. But to kind of demonstrate this is an example from a C++ or C++ textbook written by Barbara Johnston. This is a example of, let's say we talked about an ATM machine. And if we're thinking about this structurally or programmatically, we would say that you insert a card, you enter a PIN, the PIN and the account are validated. You select cash withdrawal, we enter an amount, the balance is verified. Notice the passive language in these two steps. Money is dispensed, the new balance is calculated, we write a receipt, and we return the card. So this is the structure from what happens from the ATM's perspective. So, and that would work fine. And we would say that that's a top-down approach to list the steps that the customer takes to use the ATM. Once the steps are identified, we determine the routines that are needed, and we could write that, you know, with our Python code and make that work. An object-oriented approach to that would be, hey, we really have three entities involved here. We have a bank customer, which has stuff that they're doing. We have the ATM, and then we have the bank. And as you're doing object-oriented programming, you would ask, who inserts the card? So let's answer these questions as we go along. So who inserts the card? The bank customer, right? The user. And then who reads the card? The ATM. And then who verifies account and PIN numbers? The bank. And then who dispenses the money? The ATM. Gnomes. Yes, if you have gnomes, then we could have that as a branch. They're hard to find and employ, but they do excellent work from what I understand. And then who keeps track of the customer's bank balance? The bank. Yes, so we can see, you know, if we were writing this with multiple programmers, it would make sense to say, hey, you know, why don't we have one programmer write, you know, something from the ATM's perspective, and another person write it from the bank's perspective. Would we actually have to write code from the bank customer's perspective? Yeah, we'd have to have instructions, but it would really be the ATM's job to display the instructions, wouldn't it? What about test code? Could we write maybe make some functions or some programming stuff that would actually be test code that could test the rest of the other code, and just do it and use that for the bank customer? Yeah, so so that might be a test code thing, and that's actually done. So if we do this division, this is what we get here. And if we look at these kind of make more sense. The bank customer inserts a card, enters a PIN, selects cash withdrawal, enters the amount, takes money, takes receipt, and takes card. Does that seem pretty consistent with everyone's experience using ATM? And then we think of it from the ATM's perspective. Read the card, obtain the PIN, contact the bank for validation, obtain selection and cash amount, dispense the money, and then write a receipt. And so we can see, okay, this makes much more sense maybe because I'm not like, embedding the bank stuff with the ATM stuff. And really with this architecture, there's the program running on the ATM and then there's the program running in the bank and they're communicating over a phone line. So this actually makes our code a little easier to sort out. And then the bank. The bank is just sitting there waiting for PIN numbers and accounts to come across the phone line, checking balances and then adjusting balances. And then there's about 5,000 security steps, which we're not going to list there. Does that make sense? And you can actually extend this a little bit. I have a friend who works in the bank business, and he explained how if you have money going from one account inside of the same bank to another account inside the same bank, the bank actually processes that internally. But if it's going from one bank to another bank, there's an additional step where it goes to a federal system, which then does the transfer between banks. So so the way you can think about it is if we were writing this as functions, each one of these could be an individual function that could be defined. So each of and then there could be different state that's maintained. So in the ATM, there's the ATM's overall amount of cash that's available that maybe it needs to take into account as it's doing everything. And within the bank, there's going to be each customer is going to have a customer bank account, and each one of those bank accounts is going to have a balance. So you can kind of see the structure kind of materializing from this. And if you look at the functions that get called, notice that the flow of this application runs back and forth between the different classes. So the card gets inserted, the ATM reads the card, waits for the PIN, gets the PIN, then says, oh, now I need to contact the bank, sends a request to the bank, verifies the PIN is good, waits for tells the user to enter the amount they want, then says, okay, I've got that amount, now I need to call the bank, goes to the bank, verifies the balance, adjusts the balance, okay signal is sent to the ATM machine. The ATM machine then dispenses the cash and writes a receipt and then returns the card. So you can kind of see the flow going back and forth across these classes. So the idea with object-oriented programming is objects perform the tasks, code is broken up into modules, and objects interact back and forth to obtain the desired results. One of the nice things about this is, originally ATMs were only associated with a single bank, and you had to find your bank's ATM in order to work. But now, this ATMs can actually interact with multiple banks as long as they're on kind of the same network system. And so each of these banks would actually have their own software running to manage the interactions, but they're able to work with one ATM machine, which makes things much more convenient. So the nice thing about object-oriented programming is we get to break the problem down into simpler units. There's some encapsulation things that we can do that's used more in other languages, but we can do it in Python. And it simplifies the management of large projects with multiple programmers. So does it seem logical that if you had a really large program, you could break it down into multiple classes and then just assign the classes to individual programmers? Yes, and one of the concepts with classes is, you could imagine, let's say that we had a bunch of big function libraries, and you can use this function, but before you set this thing in here, make sure you initialize this part. You'd have things like that would happen. And everyone would have to send memos out to everybody else to remind them of all the little persnickety things that need to happen with the code. You'd have to put a bunch of comments in your code, and so that people don't mess up what's happening. One of the things we can do with the encapsulation part of classes is that we can actually hide the functionality, some of the complex functionality inside the class, so that when someone uses that class, they don't have to interact with things, and there are things that can be made to happen automatically, which means that the class tends to be, it's the obligation of the programmer that's making the class to make it function no matter what inputs come into it. By using that, we need far less communication between programmers to make sure that everything works okay. So we would not be able to make the complex code that we make today without having this structure of writing classes. And that simplifies reuse of the code. So now let's try to make our first class. So go ahead and type this code out. Class person, just so I can paste what I'm doing, I'm going to probably type this out live, and then and so to make a class, you use the class keyword, and it looks a lot like a function definition at that point, except that we're using class. And then within this class, we're going to define a bunch of functions. What do people notice about this, these functions that's a little different than the functions we've defined up till now? Self. So the real difference between a method and a regular function is a method is a function that has the self parameter. Normally, if I define a variable inside of a function, is it accessible in the other functions? So if I define a variable inside of a function, is it available in the other functions? Generally, no. So for example, if I define this variable, will that work? No, because functions are declared inside of variables are declared inside of a function, normally only have scope within that function. But with self, name is available rather than just having function scope. The self variables have class scope. And so or object scope. They're available throughout this class. And so down here, notice with the set name, we're going to pass in a name. It's going to be assigned into self.name. Note that self.name is not the same thing as name. Self.name is a class variable that is associated with each individual object that's going to be created off this class. And so if I set it into self.name, down here when I say get name, which returns self.name, it will be available. And so think of the self as basically making variables available throughout this class. If it's not self dot something, it's only available locally in the function. And notice also that we have a greet function. It's got access to name as well. And so I'm going to this. And so here I can so to instantiate an object off this class. So this class really is kind of a template. And to make a person object, I have to, it's just like creating a variable. I'm going to put a variable name, it could be anything, and I'm going to say equals person, open close parentheses. And now that I have this, I can call foo.set name. And I'm going to put in a name. Actually, first I'm going to make a second one too. Bar is equal to person as well. So now I've got two people. I've got foo and bar, and I'm going to say foo is equal to, or I'm going to say foo dot set name, and then let's see. I think they put Anakin Skywalker as one of them, and then bar dot set name. Luke Skywalker. So notice so here we said self, when we did set name, notice that we only have one parameter in here. But we have one argument up in set name, but we have two parameters in set name definition. So why did it work even though I only provided one parameter? Where did Anakin Skywalker go into? Did it go into self or name? Well, it would seem like it would go to self because it's the first one. In point of fact, it actually went into name. So if Anakin Skywalker went to name, what went into self? Foo. Self gets its value from the object to the left of the dot in the method call here. So foo goes into self, Anakin Skywalker goes into name. Does that make sense? And as a proof, we can see if we put foo.name, we get Anakin Skywalker. And if we put bar.name, we get Luke Skywalker. So how many in memory is this name variable in the same memory space as this name variable? So is foo.name pointing to the same place as bar.name? Not really. Basically, what this is set up is doing is we define name one time in this class, and then when we instantiate a foo and a bar, foo and bar will get their own places in memory to store their own names. So they will have we say that they have their own separate state, which has their own sets of variables. And so even though they both share name, they have the variable name. These are two different, this is name inside of foo, and this is name inside of bar, and they are different sets of variables. Does that make sense? And so you can in many ways think of an object as basically it's an instance of a class, and it's got its own state where it has its own set of variables, but that use the same names as other objects use. And now getting back to self. And self is like one of these really nebulous things that's sometimes hard for people to understand. The reason why when we define class, we use self is because at the time you define the class, you don't know what the object names are going to be. So as a placeholder, we have self. And we're saying, hey, whatever object it is, make its name attribute be this. And then with the get name, we're saying, hey, whatever the object is, return that object's name attribute. And here, print hello, and then add in whatever that object's name attribute is. Does that kind of make sense a little bit what self is? So when we define the class, self is a temporary holder for the object that will be referenced. The object in this case will be the variable name that's applied during our instantiation, and from then on they will each have their own attributes, and the functions will use those attributes as self when you call the function. And then we can try some of these other functions. If I say foo.greet, notice that in this instance, greet just has self. So I just put open close parentheses. Foo will be passed in for self, and we will get foo.name, which we know is Anakin Skywalker. And if I say bar.greet, I'm putting no parameters, self again will this time be bar, and so we're going to say, hello, I'm bar.name, and bar.name we can see is Luke Skywalker. So it should say, hello, I'm Luke Skywalker. That makes sense? So we're going to do a group exercise, and this is convenient because you can recommend code for me to write by typing it into the message board. But we're going to write a class that keeps track of a pizza order. And so we're going to define set methods and get methods for a pizza, and then we're going to get a price out of this pizza. And so we have set, get, and then the get price. So so we often will define classes using UML, and that looks like a diagram like this. And you put the name of the class at the top of it, and then you have your attributes. And your methods. And so we're going to have a set size. I'm sorry, that's attributes. So we're going to have a size attribute, and we're going to have a set size. And just to make it a little bit clearer what's going on, I'm just going to put self self.size. And so we're going to have a set size method and a get size method. And then we're going to have a self.toppings. So we're going to have a set toppings and a get toppings. And then we're going to have a get price. And the price will be, let's say for small, maybe we'll do say $5. For medium, we'll say we'll say $7, and a large we'll say $9, and then we'll say $1.50 per topping. So this calculation has to go into get price. Does that make sense? Okay, so how am I going to kick off writing this class? What's the first line I'm going to use? And sometimes my questions are not hard. Well, we're going to start off just writing the class. So, well, yeah, we should have a header. So, let's see, pizza .py programmer entire class, and then date. Class pizza, yes. So notice that this is very similar to defining a function, right? Or with the define statement. And often, and by convention, normally in Python, I think we tend to make the classes capitalized. So now we saw, with our UML, we had get and set pizza, get and set size, get and set toppings, and then a get price method. So what do I do next? Yeah, start to define the sets. How do I define a set? Let's do the first one. Let's do the size one. And we can look at the other program. Yes, define set size. So like that. What do we need in methods that we don't normally have in functions? Self comma size, yes. So we need the self because this is inside of a class and we want to be able to preserve information that we get. And we also need to pass in what size we want to set. So what do you think we should be passing in for size? Small, medium, large, or like the size of the pizza, 8-inch pizza, 10-inch pizza, 12-inch pizza? What do people prefer? Small, medium, large? Yeah, I think so too, because if we put in this size, we're gonna have to validate that, the size elements. Small, medium, large probably will be easier to validate. So we get the size. What do we need to do with the size variable that comes in here? And this is really kind of not super obvious when you're first doing this. And in Python, it's a little nebulous to begin with a little bit, but we need to, let's look at these other functions, or this other example. We get in a variable here, and then we store it in self. So how would we do this with set size? So self.size equals, we do that, we're really using that variable coming in. Yes, self.size is equal to size. So recognize that self.size is not the same thing as this parameter that's coming in. This is, in fact, this could be blah, and then this would be blah. So basically, we're bringing something in here, and then we're setting it to self.size. It's just that blah would not make a lot of sense what's going on here. So these two will look the same, but they're not the same variable. This is a size attribute stored in the object. This is the parameter size. Does that make sense? And if it helps you, you could do something like this. And that would be perfectly okay. Say, oh, this is the new size coming in, and we're setting it into self-size variable. And that's okay if you want to do that. I'll do that here just to make it obvious what's going on. So now we have a size attribute and we have a set method for that size attribute. What else? What should we do next? Do a get. So how do I define a get method for this? So define get size. What comes next? Do I need that? Realize, and then until we use it, it's not going to be super obvious. But get size is going to be used from when we use this class to get the result out of it. We're not actually setting anything into it. So for the get methods, we will just return whatever is currently stored in self.size. And so this is the pattern you're going to get. Set method has the word set in it, and then whatever the name of the attribute is. It takes a self parameter and one parameter that gets set into self. The get method is parameterless other than self and just returns self.size. So sets don't return anything, gets return things. Sets take a parameter, gets don't have a parameter. Does that pattern make sense? And there's a lot of different ways you can implement a class, but this pattern seems to work well in a lot of cases. And we'll see kind of why once we get further along. So now we're going to do the same thing for toppings. So how would I define my toppings set method? Okay, we can do the get first. So get toppings. Let's do the set first so that we can kind of maintain pattern. So set toppings, and we're going to have self and toppings. And then we will just say self.toppings equals toppings. And just to do the what I'm doing here, I'm going to put new toppings so that it's kind of obvious that's not the same thing. And then we say self.getToppings. And again, the get has just self and just returns self.the attribute. So I'm going to play around with this now. I'm going to start the main part of my program and realize, just like functions, nothing happens at this point. All that happens is that pizza is defined, its functions are defined, but we haven't actually done anything yet. In fact, if I run this program right now, notice that nothing happens. So while we defined our class, until we invoke it, it doesn't really do anything. And so I'm going to create 2 pizzas. And to create a pizza, again, it's get a variable name, whatever you want that to be, and assign into it the class, but with notice it's the class with parentheses after it. It looks like a function call, and we'll learn more about that in a bit. But this call to the class actually instantiates a place in memory where pizza1 will point to, which will store the information for pizza. And for pizza, we're going to store a size and a list of toppings. And once we have those, we can do something like pizza1 dot set size, and we'll make this one a small, and then pizza2 dot set size, it'll be medium, and pizza1 maybe we'll set its toppings. I don't know, pineapple and anchovies. Everyone good with that? Set toppings. Oh, I gotta spell it right. I don't know. Green chili, yes. Perfect. Actually, this needs to be in a list, and so does this one, because we have one toppings is one parameter, so we're going to put everything in here as a list. And then we'll maybe say print pizza one get size, comma, with pizza one dot get toppings. And then we'll do the same thing with pizza two. Now you may see an error like this, or not really an error, but it says bound method pizza get toppings of main dot pizza object at 2368 FC07088. What did I do wrong? So what I did wrong was right here. I referenced the method, but I forgot to put the parentheses in to say, hey, actually call the function. So get toppings takes no parameter, so I have to at least put an open close parentheses in there. And now I get small with pineapple anchovies and a medium with ham and green chili. Pizza set toppings. Make sure that the spelling is correct. So like if I misspelled this, I think I would get the same error. Let me see if I can make the same error happen. Is that what you got, Richard? Yeah, so if I misspell my names, then I can get those errors. To fix it, just what you might do is double click on the method, and then so if you double click and hit Control C and double click and hit Control V, you can just copy those over and make sure that the spelling is correct. Is that working for everybody? What error are you seeing, Brendan? Ah, so this one, get size missing one required positional argument. So get size, probably what you have is you have self dot size. And if I did that, let me see if I get your error to happen. Looks like that, right? So what you need to do is get rid of this. The get methods just have self. Anyone else not getting it to function? Everyone with me? Okay, so now, okay, this is nice. We can store information in this, and that is one of the main purposes of a class. You can think of it as a container for information, and I don't have, if you didn't have this, we would have pizza1.size, or you'd have, pizza1 size, pizza2 size, and then pizza1 toppings and pizza2 toppings. And then if we had 100 of these, we'd have like pizza 100 size. It'd just be a lot of variables. So you can think of it as a way of, hey, this is what the standard information is I need for a pizza. I define that one time with my class, and then I get to reuse it. But we can also do things that do some actual work. So we're going to make a get price. And notice the get price is really going to be a read-only kind of thing, because we're going to have a get, but we're not going to have a set price. It's usually considered bad business practice to let your customer just set the price arbitrarily. So we're going to calculate this price off of the attributes. We have self.size and self.toppings. And so now we need to figure out this price. So give me some suggestions on how I can calculate the price of this pizza. And I think we had $5 for small, $7 for medium, and $9 for large, and then $1.50 per topping. Yes, correct. So what code would I put in here under get price? Now, at some point, we're going to need a return. Well, if they put small, medium, and large in here, they're going to have to look at that and make a different choice for each. So we're kind of going to have to use an if statement. What would this if statement look like for small? Yeah, so if what's small, though? If set size? What did we set size into? Yes, if self.size equals small. And then maybe we just have price is equal to, let's see, we had 5, right? What would we do next? Good question, Laura. Pizza 1 or pizza 2? Well, when we're defining the class, pizza 1 and pizza 2 have not existed yet. So self is what we use to represent what might be pizza 1 or pizza 2. Elif. And then what would we look at? Yeah, self.size is equal to medium. Price would equal 7.0. Then what? Yeah, then else price will equal 9. So it's kind of like this is going to default to large if you don't like put in the right thing. That's probably okay for now. Later on, we can talk about, we'll learn maybe a little bit more about how we could do validation, but for now, that will do. So now what's next? Yeah, calculate the toppings price. So how could we do that? How can we get the number of toppings from toppings? So toppings is a sequence. Is there a function that allows us to know the number of elements in a sequence? Len. Yeah, index would get us the index of a thing inside of the list. Len will get us the size of the list. How do we use the len function with what we've got? Well, maybe look up the len function. How do we, that doesn't look like quite how we use it. That would set len into toppings. And we don't have, within the class, we don't have a pizza one. Well, set toppings is the function close. So len is actually, in fact, maybe we can play around with this in the interpreter. So if I have a list, that returns what's in that list. And if I look at pizza one dot toppings, that's my list. And if I said len of pizza one dot toppings, I would, oh, I guess I didn't define it really well. Let's do pizza two. That's more like it too. I put a comma in when I defined pizza. I needed to have these separated. So given that pattern, how would I do that though within the class? Because I don't have pizza one or pizza two. What substitutes for pizza one or pizza two from within the class? Right. So what do I put in here? Well, new toppings is the parameter, but what do we set new toppings into? Yes, there we go, Ron. So len of self dot toppings will have is the number of elements. What do I need to do to that to get the price? If it's $1.50 per topping. Yeah, so I can multiply by $1.50. And what do I need to do with that whole thing? Well, get price, we actually don't, it's not, and this is one thing with classes is we actually don't want to print from a class because later on we're going to learn how to do GUI programming, and we would like to be able to reuse our classes. You want a class to be able to work with either a console application or a GUI application. So often we don't print from the class. Yes, set a variable. What variable are we using to keep track of price? And sometimes my questions aren't hard. Yes, price. We're going to accumulate using, plus equal it. That's the same thing as saying, we could say price equals price plus this calculation. But of course, the shortcut to that is just saying price plus equals this. So we don't want to say price equals that because then it will obliterate 5, 7, and 9. Instead, what we do is we're going to add whatever this calculation is on top of what's currently in price. Does that make sense? And then what do we do with gets with at the end of get methods? Yep, we're going to return it. And so now we have a get method for price. Then we can add that in here. I'm just going to put price. I'm going to go to the next line so that we can see it. So price, comma, and then I'll just call pizza one's get price method. And then I can kind of do the same thing here. Pizza two get price. And so, the kind of nice thing is I get to define this behavior one time and I get to use it multiple places. And so anytime I want to deal with pizza, I have a nice class that can run this for me. And so small with pineapple anchovies, price will be $8, and medium with ham and chili, the price will be $10. Does that make sense? Now, question. Would it be nice to be able to maybe, rather than having to construct this each time, make a method in the class with this string here? So we can do that. We could actually make a method, maybe define, I'm going to just call it get summary. Again, we have to have self. And I'm just going to kind of repurpose this. You're going to, well, yeah, actually, I think I'm just going to write it from scratch, just a little easier. I'm going to return. Now, I don't have to call the get size method directly because I have access to the size right in here. So I can just say return size plus, and if I do this in here, well, the size is a string, so I'm probably okay there. So size plus width plus, I'm doing string concatenation because these commas won't work within if I'm just returning a value. And then we're going to need to turn a string into toppings, or turn toppings into a string because it's a list. So I'm going to use the string operator plus and because I'm using concatenation, I need to put my spaces in there. And I think I'm going to do this with in the multiple steps. So I'm going to do it this way. I just think it's easier to see what's going on. Now, right now, price is actually not being stored anywhere. And so we kind of have a problem here. I can actually call get price. We'll get it to work here, and then we're going to try to fix this to be a little bit more elegant. And we'll see if this works. But I should then just be able to say pizza1.getSummary here and pizza2.getSummary, which kind of cleans up my code in main. Let's see if that works. I get an error. Size is not defined. Let's see. So I got size is not defined here at the line, at this line here. What do I need to do? Self.size. Now I've got an error. Toppings is not defined. What do I need to do here? Self.toppings. And now I've got get price is not defined. So it's saying here, name error, get price is not defined. But I got it defined up here. What do you suppose I have to do to run get price from in here? Can you hear me now? Might just be transient from the network. So, okay, so what I was saying is, what do you, we're getting an error here. I'm going to rerun it so I can clean it up a little bit. So we see that it says, name error get price is not defined. What do we need to do here? add self. And that's just a misspelling. And then it works. So we were able to make a get summary. We had to call this function from inside. So we can call one method from another. Why do you suppose we have to provide self in that method call? Yeah, we have to we have to reference self because realize all these methods need to be called in reference to an object. And within the class, when we need to call a method, we put self to represent whatever object is being passed in here. If we didn't do that, it wouldn't know what get price was because it would assume it was some method that's just floating somewhere. So whenever you're calling a method from another method, you put self next to it. So, but this looks good. It kind of makes sense to have an attribute for price because really price is not, there's no attribute for it. We just have a get method that does the calculation, and every time we want to get the price, it's going to redo this calculation, and that's kind of potentially expensive in processing power. So let's see. Actually, I think I'm going to hold off on that part, how we fix that, because there's some more things that we're going to need to look at that we'll see in the next lesson. But hold on to that thought that there could be a more elegant way of doing this, and realize that in this, every time you get the price, it's got to recalculate it. But really, we probably should only have to calculate this one time. Once you set the size and you set the toppings, the price should be set, and then you should just have to reference it. So think about that for next time. Is there a way we could set things up so that this gets calculated off the sets, and then when we reference the price, because if you think about it, price is going to be referenced multiple times. The sets are probably only going to happen one time for this object. Is there a way we could set things up so that the calculation only happens one time whenever or maybe only a couple times when we change the sets? And keep that in mind for the next class. So that's all. I think that's all we're going to do with that intro to making a class. Are there any questions on how this class goes together? You got none and none? Yes, self is a special keyword for Python. Huh. So let's see if I can reproduce that. What if I did this? No, I would get the object reference, so that doesn't likely it. What if I misspelled get summary? I would get an error. What if I forgot the return? Could that be it? Does that fix it, Sawyer? Yeah. Any other questions? Yes, so if you want to email it to me, Laura, I can take a look at it. So that completes the presentation for this section. The rest is lab time. Program 6, let's see, I have to do for March, so next time.